Hello friends, in this lesson I will explain the structure of the breadboard on which we install the circuits and how to use it to check whether the electronic circuits work or not. Breadboard is used to check whether the circuit works or whether the connections are wrong at the design stage before transferring the electronic circuits to the print circuit. In other words, it is used to make tests on the circuit. It's a useful material to install and test electronic circuits practically and to connect circuit devices without soldering. Thanks to the breadboard, it is very easy to connect the circuit devices to each other and to the conductors. Since there is no need for soldering, you can easily disassemble and reconnect the circuit devices. The aim here is to check whether the circuit works or whether the connections are wrong at the design stage before transferring the electronic circuits to the print circuit. As you can see, breadboards in different sizes, colors, structures are widely used today. Many circuit devices such as resistor, capacitor, coil, diode, transistor and LED, which have long metal pins, can be attached to the breadboard. After installing, the circuit devices, their connections and paths with each other can be provided with jumper cables. These cables are very useful for interconnecting circuit devices. Well, how is the structure of breadboard? Now let's have a look. Breadboard is a string of conductors arranged in a plastic case and insulated from each other. There are certain number of holes on the breadboard. Circuit devices are attached to these holes. The pins of the circuit devices touch each other through the conductors under the holes. The holes on the breadboard are connected from the bottom, that is, behind the breadboard. This connection is provided by metal clamps. All holes in the red and blue lines at the top and bottom are connected horizontally from the back. The connection principle of the holes of the breadboard is shown here as follows. Likewise, in the middle, the 5 holes from A to E and from F to J are vertically connected to each other. There is no connection between E and F though. So, what does that mean? Let's have a look. I will try to explain it making a simple circuit connection. There is a 3 volts power source and an LED. Let's put this LED on the breadboard and make it light up. And then let's install the LED between positive and negative. Let's make the positive connection here and the negative connection here. When we make the connection in this way, the LED will light up. It doesn't matter if the location of the LED changes. All kinds of LEDs will light up. What we need to pay attention here is that the long anode pin of the LED should be connected to positive and the short cathode pin to negative. Likewise, when we connect the LED as here, it will light up. It doesn't matter if the location of the LED changes. It will light up anyway. If we use a 9 volts power source instead of a 3 volts power source, we need to connect a 330 ohms resistors in series to LED. As here, when we connect all circuit devices in series and connect a 9 volts power source to them, we can make the LED light up without any damage. The circuit we installed on the breadboard is exactly the same as the circuit you see at the bottom right. To sum up, while the holes in the positive and negative columns on the two sides are interconnected, the holes in the 50 rows from A to E and F to J in the middle are interconnected. On some breadboards, the red and blue lines are not overall and are interrupted in the middle. In these breadboards, the holes in the horizontal row with the red and blue positive and negative feedings at the top and the bottom are connected to each other from inside up to half. If you want it overall, we need to add a small cable where the interruption occurs. Now let's have a look at the examples of series, parallel and mixed connection of resistors on breadboard, summarizing what we have learned so far. For example, here 1.5 kilo ohms and 1 kilo ohm are connected in series. Here 3 resistors are connected in series as well. And again here 1.5 kilo ohms and 1 kilo ohm are connected in parallel. Here 3 resistors are connected in parallel. This example includes an example of both a parallel and a serial connection. We also need to insert the integrations in the middle of the breadboard. It is used in this way. Let's take a look at the common mistakes made on the breadboard. One of the most common mistakes is to plug 2 pins of a circuit devices into the same 5-column or negative and positive inputs. Such a connection short circuits 2 pins of this device and it is incorrect. Another mistake is installing the circuit devices randomly. We need to install the circuit devices carefully. If we plug it in this way, we may increase the possibility of short circuit by touching the resistance pins to each other. Another mistake is also to install the resistors in this way and think that we are making a serial connection. In this connection, both resistors are independently installed on the breadboard because the 5 columns in the middle were not horizontally connected to each other. So, such a serial connection is not possible. This is the structure of the breadboard. I hope it's useful for you and you like it. Hope to see you in our next lesson. Thank you and goodbye.